in order to liberate soap. The apparatus and materials to be taken by Umi Salma.
So for the apparatus, we needed beakers, measuring cylinders, Bunsen burners, tripod stand, coconut oil, sodium hydroxide, sodium chloride salt, filter paper, and water.
So for the procedure, firstly, we made a solution with 15 grams of sodium hydroxide and 50 mils of water. Then we added 60 mils of coconut oil into the solution of potassium hydroxide, and then we stirred over a flame for 10 to 12 minutes. After that, we slowly added the solution of sodium chloride, and then a suspension was formed. After the suspension was formed, we sieved it and then kept it for 30 minutes to an hour and molded it. Then it was able to form the soap. Umi is going to this soap that was formed is actually real and it produces a lather. So she's going to take the spatula and scoop some of it and put it into the test tube. Then she will add water to it. And then she will shake it. You can observe that a lather is being formed. When we prepared the solution of potassium hydroxide, we used blue and red litmus papers to test it. The blue litmus paper neutral, and then the red litmus paper turned blue. This is to show that it is a basic solution. When we made the solution also, there is an industrial method of saponification, which is the liquid soap. And then the advantages of saponification. Soap is used in everyday life to wash, and then it is also used in fire extinguishers, which can be used to control fire. Also, if you have a after the experiment, we concluded that the soap formed is hazardous, and also soap can be used in different forms. We also concluded there was soap and glycerol. Saponification can also body as because the fat in the body also reacts with the bases in the body to neutralize it. Saponification can also be used in food to test the
My panel of judges and here with me is Chalia Mirigaji. We are going to talk about sound electrifying and how it can be used. So first, what is sound electrifying? Sound electrifying can be defined as the conversion of sound energy into electrifying energy. And we should also know that sound energy through the use of transducers and it creates a cavitation bubble. Last presentation, some questions were asked by the judges whether sound energy why is sound energy not widely used of sound energy? So firstly, the use of sound energy is that in hospitals to use ultrasounds to check pregnancy. And in large-scale farming, we use sonar to detect, because fishes use sound and waves to communicate, we can detect their waves. By detecting their sound waves, we can catch proportions. So thirdly, we use sound energy to, when we hear sounds in our mechanical, when we hear faulty sounds, we use it, like when we hear a faulty sound in our machines, we can use it to detect it. Let's say now your brake is having a problem and it's screeching. It's from your sound, by the sound that it's making, that's when you know that it's having a problem. So what I'll come to is the main question that one of the judges asked in the last presentation. Why is it not widely used? Okay, so sound energy, we use the galvanometer to detect the sound energy. You need it to fill a very big room. So we cannot be using it every time. A normal person cannot use sound. So I'll give my co-scientist, Charlie Amirigazi, to aim and
the apparatus that we used was discarded speaker, cardboard paper, glue, a wooden surface, wires, and a galvanometer. Basically, the aim, communication, recording. Sound electrifying in recording is basically the processing of the audio signal, analysis and measurement. Such techniques like distortion, signal processing, such techniques like dynamic range compression that widely enhances its effectivity, and then amplification. Most and oftentimes engineers use other techniques like distortion to create exciting and dynamic listening experiences for users. In conclusion, we all know sound constantly fills our acoustic environment. Like all energy, sound energy has the potential to generate electricity, just like the sun provides unlimited solar energy and the breeze provides wind energy. Sound energy is renewable because sentient beings and insentient objects alike constantly produce sounds. Thank you.
Good day, judges, timekeeper, fellow, di- fellow, sci- fellow scientists. I'm Daniela Daniel, and this is Stella here, and we are from Conqueror House, and we're here on on an experiment topic, phototropism. First, what is phototropism? Phototropism is the movement of plants towards the direction of light. It could be any light, it could be sunlight. And also, the aim of this experiment is to show the bending of plants towards the direction of the sunlight. Then, the hypothesis of this experiment is brighter light gives stronger and better growth. Then, the apparatus we used for this experiment was a container for a cardboard box, a seedling, a granite seedling to be specific, and soil. And I'm going to
The scientific background of this experiment is as early as 1880, when Charles Darwin noted that phototropism is especially important for germinating seedlings, whereby the emerging shoots must grow towards the light to survive by maximizing the capture of light for photosynthesis. And finally, Charles Darwin came out with the following postulations in 1880 that said that phototropic response was lost when the tip of the emerging shoot was cut off or covered by an opaque cap. And the second one is, he said that covering the base of the stem did not block phototropic bending. And what we observed is that the plant started to bend towards the direction of the sunlight, as you can see. And phototropism is most often observed in plants, but can also occur in other organisms like fungi. And the real-life application of this particular experiment is that you can apply to agriculture, which helps in optimizing crop growth and yield, and also in horticulture, which is the growing of plants, which can help in pruning plants, and also in urban planning, like in urban gardens. You can use it to help the plants grow or help the plants to grow healthy. And what we concluded in this particular experiment is that finally sunlight affected the plant and it started to bend towards the direction of the sunlight. And we concluded that the tips of the plants have strong sense of sunlight, and thus it bends towards the light source, while the middle section activates protons, which decreases pH acidity, decreases acidity in the plant cells. Thank you.
Wow, wow, wow. Please, are the members of these houses here? Are we all here? So why are we so... Even when your houses are presenting, you don't say anything, you just sit. Do we understand what's going on? Do you understand the experiment? Okay. We'll get to know what you've learned. Sir.
First of all, I want to appreciate the amount of effort that has gone into each of these presentations, right from the first one that we saw. And I must say that the word science fair is appropriate because even though this is a competition, I am that much more enriched with my knowledge and the fact that these are young people explaining things that their high school counterparts abroad are also doing. If you translate the cost of the naira into the dollars, you would see that Great Blessings learners are really at par with their mates globally. So I want to start by commending all of you. I also wish to commend your educators. You didn't do any of this thing in isolation. That's just my general comment. I'm saying this not just as the director, but also as a judge. I'm quite impressed with your presentations and the fact able to take correction. The hallmark of excellence is the ability to learn from one's mistakes. And in that wise, I want to commend Valiant's House because I wasn't here the last time. I happened to watch it online and I remember the comments. Immediately, Bakai started talking. I said, okay, these people actually literally went back to the drawing board. I wish there was a demonstration, but I know that it would be difficult to test the solar oven indoors. But I don't know, it's a bit of a sunny day. Is there something you can put between now and when the competition is over? It will really enhance your presentation if you can have a practical demonstration at this point. It's an experiment. For the Vision House, very pragmatic and realistic presentation. But I have a question for you. Is it any kind of water that can produce that saponification effect? Can you tell us what would be the limitations there? You use? Okay, so so it may not, is it every distilled water that can work? Every distilled water, okay? Now what is it about the distilled water? There's something I'm looking for. What is it about the distilled water that makes it possible for the suds to appear, for it to become soapy? The quality.
It is because the distilled water is pure, as it is the vapor of boiling water that has been trapped and condensed. It's because the distilled water is the purest form of water to use, because it is formed from water vapor of boiling water, which is trapped and condensed.
Okay, that's the textbook answer. But you know that there's what they call hard water and soft water. What makes the water hard? Do you know the difference between what makes water hard and soft? Okay, so let me ask another question. Is it hard or soft water that can sod? Can you make soapy water from hard water or soft water, or none?
From soft water.
Okay, so what so we are satisfied that you actually understand. But mentioning distilled water would not have brought out the fact that if you use hard water, there's no way it will be soddy. Haven't you noticed sometimes when you're in certain places and you're doing your laundry, and no matter how much soap you put, it just will not foam? It's because the water is hard. But what can you define hard water for us, for the benefit of, for those of us that don't know the difference? Do you know? Yes, please define.
Hard water is water that doesn't form lather with soap.
This is a very smart, but what is in the hard water that makes it not form? There's something also about the hard water, because it doesn't, that is just for soap, but it also has challenges with other kinds of things. So maybe your reading was limited to your experiment. So I will leave that for the Chief Judge to tell us a bit more.
Okay. Hard water has chemical constituents in it. I think it's magnesium oxide, right? Yeah. Particles of magnesium oxide in it from my chemistry in secondary school. Because as an architect, we don't do much of chemistry. No matter how much soap you use in it, it will never ladder. It will keep on, your soap will keep on finishing, and there will be no ladder to even wash what you want. That's my question for this thing. You've done saponification very well. You've mentioned application of saponification about fatty acid and other things, which is good. You've read it, but also you should know that at the end of making your soap, you should know where it can be applied in. That's where Prof has mentioned this thing. So you have another, or should I just round up? Okay.
Our chemistry teacher said that in addition to the magnesium, the calcium is the other thing. Yes, and she should know because she's a master of chemistry. So, but this is very good. I hope you are paying attention. You see, this is not meant to be abstract. Learning should not be pure cement. How do we deal with so many other areas? I don't know if architecturally I would like to just add some of the things that you can use, not just the saponification, but the other things.
Confidence, you are. Yeah, that is what is trend. Healthy quality is the way to go, and even for the use of solar ovens, I took note that you mentioned that it doesn't get up to 100 degrees while producing heat for food. But then there are other ways that this can be applied, right, to life situations, right? You rightly said warming your food, and other things that don't require so much heat. I would just like to add, I know the MC noticed that the House members weren't really participating, and I just got the feel that you got lost, maybe because it sounded too technical for you. So maybe in further presentations, you just learn to use simple English, right, so that other people too will connect. Well done. Good job, all of you, especially the ladies.
Sorry, I want to ask something about the solar oven. It's a good thing that we're going to save. Gas is very expensive. Electricity is expensive. So we're going for the natural way. So, but all the materials in that listen, they don't look durable. You know, you are going to be cooking. Yes, maybe the first 1, 2, 3 will not have effect on the, what's this inside? Styrofoam. You don't have styrofoam, but constant heat on it, despite the fact it's not 200 degrees. It's plastic now. It will tend to wobble and other aspects. So if the styrofoam, I believe the styrofoam and the foil are just to lag heat, right? It's for lagging effect and all those things. So if you have taken care of the lagging effect, why not add a durable material in between or in the outer shell? Instead of cardboard, styrofoam, these are all materials that are not durable. And this is food. Food, we know, is always in pots and pans, you understand? The reason why it is in pot and pan is so that you cook today and cook tomorrow and cook next tomorrow. You understand? Because of the heat, something hot inside. So this material, in my observation, might have problem of lasting for subsequent cooking, except if it is one-time cooking you're thinking about. Yeah. So your experiment should also consider this is a phone. What will happen if this phone break? Will it crack? Okay. They now said, okay, they'll put Gorilla screen on it to help it not to crack. You understand? So you two should think of something durable that will still give the same result that you're looking for, in addition to that. And the phototropism. What is the opposite of phototropism? Have you read that one? You know, it is growing towards light. But there's an instance where it grows away from light also. It once in a while it goes away from light, especially in plants that don't need much sunlight. They grow away from light. So you should look into that also. I think there's another word for the opposite. I've forgotten it. Agri-science was very good during our time. So we learned a lot about all those things. Thank you.
Right. A round of applause for them. Wonderful. Okay, you can let's have the third experiment. You can take this away so that the third experiment can be displayed. Are we ready?
Second.
Okay, so before oh, sorry. Third presentation, second experiment. From what I have here. Okay. Before we go on, please, can the members of the house, somebody just tell us what you've learned so far? We've had 2 presentations. So can you prove to us that you're not just watching, looking like what's going on here? Yes, anybody? Want to say something? Anybody? From any of the houses? I learned something from that sound electrifying. I like to eat a lot of fish. So I was like, okay, so fish is beginning to get so expensive. Maybe we could use that to catch more fish. Who's going to join me in that?
Sorry, ma'am, can you ask them to bring in all the experiments? We don't want this going in and out. No, they should put them on the ground behind. That's the instruction. So they should bring in 2, please. We don't want this.
All right. I believe you can hear me. All houses, please bring in the last 2 experiments. Bring in all the remaining experiments you have.
They should just put the second one down. Yes, yes. Okay, let's use this time to score. Okay. Let's see.
Conqueror House. And Victory House. Victory House, where are you? Right, all participants, please come up. Okay, please, presenters for all the houses, please come out. I can't see Valiant. Presenters for Valiant House, please come out. Right, I need to explain something. For some of the experiments, the contestants explained that they can't bring it in and drop it because it's something they have to do immediately. That's why it's not here.
It's okay.
Okay,
But they
so
produce the time.
yes. All right. For the third experiment, first we have Valiant House. They will be doing an experiment on extraction of DNA from banana. Extraction of DNA from banana. Conqueror House will be doing a presentation on electric bell. Vision House on growing bacteria, and Victory House on food test. So we'll be taking it in that order. Valiant House, let's put our hands together.
Good morning. Good morning, everyone. My name is Miracle Nathaniel, and we're here to represent the Valiant House Group, and we're here to perform an experiment on the extraction of DNA from a banana. The extraction of DNA have been seen as a major breakthrough in the field of molecular. These have been seen as an advancement in the life of people, and is used to detect genetic diseases. As we all know, the deoxyribonucleic acid, which is the DNA, gives instructions to every living thing, which include animals, plants, and human beings. So the materials that are needed for this experiment include ripe bananas, half cup of water, polythene bag, narrow glass, narrow wooden stair, and teaspoon of salt.
Of the procedures in carrying out this experiment. First, you carry out your alcohol, put it inside a freezer to allow it to chill. Then you carry your banana, cut it into half, then carry it and peel it and put it inside this sealed bag. You mix the water with soap and 1 spoon of salt. Then join it together with the banana. You mash it softly to avoid spillage on the table. After that, you use the coffee filter to sieve the water. The water will come inside, the banana mixture will come here, and you pour it inside this beaker. After that, you carry by that time, the alcohol is already chilled. You carry it and you pour it inside the banana mixture. If you allow it for 10 to 20 minutes, this will be your results. The banana DNA will come up in a white form. The aim of this experiment is to extract DNA from banana, and is to learn that we can extract DNA from any fruit or substance. Thank you.
The results will observe that the distinguished substance at the surface of the liquid is the DNA, which contains millions of cells that makes the banana a living thing. So as you can observe, this substance at the top surface of the liquid is the DNA. So is the banana DNA. And also, as she earlier mentioned, the materials that here are used for the preparation of the banana DNA. As you can see, the spoon is here so that we can be able to extract the DNA from the banana.
Good day, everyone. My name is Jola Konji. And with me here is Derek Dung. We are representing the Concro House, and the title of our experiment is the electric bell. The aim of this experiment is to design a device, that is the electric bell, which will be used to provide a cheap and reliable means of communication in alerting the occupants of a building.
The hypothesis: when the power is running through the circuit of the bell, the striker is drawn towards the bell through an electromagnet which strikes it.
So, when testing electric bell, we observed that when these two wires are connected, current passes through the bell. Current passes through the battery into the bell and through this electromagnet, and then the electromagnet becomes magnetized, which attracts this metal strip, and in the process it hits the gong. But as the metal strip is attracted to the electromagnet, contact between these two copper strips, the contact is broken, and then the electromagnet becomes demagnetized, which makes the metal strip to go back. So the forward and backward movement all gives rise to the working principle of the electromagnet.
Scientific background of an electric bell. It was invented by Alexander Graham Bell in the year 1876, and the electromagnet was invented by William Sargent in the year 1823. The apparatus used in these experiments are battery, nut bolt, gong, flexible metal strip, wooden board, electromagnets, and wires.
So concerning the procedure in which we made this, first of all, we got a wooden board. Then we started making the electromagnets. The electromagnet is a temporary magnet, and we made it by wrapping telephone wires around these bolts. We made sure to avoid breaks when wounding the wires through the bolt so that it will be fully magnetized. After that, we mounted the electromagnet on the board. After that, we also mounted the bell itself. Then this metal strip, we cut it out. It's a flexible metal strip, so it moves forward and backward. And after that, we attached this copper strip, these two copper strips to the metal strip. Then we connected one end wire of the electromagnet to one end of the copper strip. We also connected another wire to the end of the other copper strip, which will act as one end of the batteries, while the free wire of the electromagnet will act as the other end of the battery. That's the positive side. And so when we tested it, it gave rise to the electric bell.
The electric bell is applicable in schools to alert the end of a period and is used in hospitals for emergency periods. Is used as fire alarms during fire outbreak.
To conclude with, the electric bell is a mechanical or electronic device which works by the principle of electromagnets. And an electromagnet is a temporary magnet. We hope that with this experiment, we have been able to enlighten you. And I hope that it will prove useful to you when the time comes. Thank you.
Good day, everyone. Panel of judges, educators, and my fellow learners. My name is Pinya Adamu, and here my co-scientist is Josephine Emmanuel, our representatives of Vision House. Today, the our experiment is called growing bacteria. The aim of this experiment is to grow bacteria in a laboratory using the agar culture medium. And for our hypothesis, knowing that bacteria are all around us, it is very important to keep a high level of personal hygiene at all times. On a background level, knowing that bacteria, they are a unicellular organism which help in various important functions, such as they clean oil spillages, they aid in digestion, and they secrete vitamins. Also, the bacterial culture is a method of multiplying dozens of bacterial cells under a controlled manner, and of which the agar it serves as a food or nutrients to the growing bacteria. All right, now I'm going to hand the mic to Josephine Emmanuel, who is going to tell us the materials that we used in this experiment.
The materials that are needed for this experiment to take place are, we have the Petri dishes, 9 centimeter, and then we have hot water, or water general, and then we have microwave oven, we have microwavable bowl, and then we have nutrient agar, and then we also have cotton swabs and sanitized wipes, and then we also have carton. We also have Ziploc bags, and then for the experiments also take place. These are all things that you need.
Okay, so for the procedures that we follow in achieving this experiment, firstly, we empty the plastic bag of nutrient agar into the beaker. Then we pour hot water in. We stir the mixture. We put the beaker inside a microwave oven, and we set the timer for 3 minutes. Watch for when the mixture in the microwave begins to boil. Next, you remove the beaker from the microwave oven and allow it to cook for 3 to 5 minutes. Once you fill each petri dish half filled, you cover the petri dish and allow the solution to cool and harden for at least an hour. Dapping a cotton swab in water and rub the end of it on surface faces, just like a smartphone. You open the lid of the petri dish and you lightly draw a squiggly line upon the hardened agar solution. Then you close the lid back. Then use a sanitation wipe to clean the surface of the phone being used for the sample. Then you take another sample in another petri dish to be tested. Feel free to use any kind of surface you wish. Tables, door, TV remote, even your own shoe. Next, you place the sample petri dish inside a safe and a dark place to allow the bacteria to grow. for its safe disposal. At the end of all, that multiple rounds of bacterial growth were seen, or bacterial growth were seen in the petri dish. And also, we know that these are bacterial colonies of which were formed in the petri dish when this experiment took place. In conclusion, while most environmental bacteria are not harmful, once under control, they form dozens of colonies, which in the petri dish, once they are exposed, it can become very harmful, which can cause several diseases like cough, cholera, malaria, or any other. And of course, that is why it's good high level of this bacteria.
Good morning to our esteemed judges, our teachers, and students. My name is Seyo Adam, and with me here is Arabella Maji, Irene Gaku, and Ehi Adamu. And we're representing Victory House. The title of our experiment today is Food Test for Nutrients.
The aim behind the experiments is to find different ways of testing for the presence of nutrients in the food we eat daily.
Our hypothesis is that at the end of our presentation, the different nutrients in the food we eat and their nutritional value should be recognized.
For our first test, we will be doing the iodine test, which is testing for carbohydrates. The materials needed are the iodine solution, our carbohydrate food, which today will be bread, dropper, and a clean palette. So first off, we cut a small piece of the bread and we put it in a clean palette. We add a few drops of the iodine solution onto it, and if there is a blue-black coloration, it indicates the presence of carbohydrates in the bread.
For our second test, we'll be doing the fat and oil test using blotting paper. Now, the materials used in this test is granite oil and the blotting paper. We are to rub the oil against the blotting paper, and if there is a translucent effect, it indicates the presence of fat and oil.
Next, we'll be testing for protein using the foam test. Now for this test, we'll be using the test tubes, the dropper, the spatula, an egg, and water. Now for this test, we put water into the test tubes, and then we immerse the egg in the water, and we shake it vigorously. Now, if a foam is produced, it indicates the presence of protein in that egg.
As you can see, there is a foam there which indicates the presence of protein. Now for our fourth and last test, we're doing the alcohol test. The materials used in this test are the alcohol solution and a beaker, an egg, and the test tubes. First off, we immerse the egg into the alcohol solution. And if a coagulating effect is being seen, it indicates the presence of protein in an egg. As you can see, the egg has coagulated, which means there is protein in an egg.
Now, the theory involves adding a reagent to a food sample, which changes color depending on the biological molecules present in that food sample. Sometimes you crush the food or add water to it before adding your agent or chemical that indicate the presence of substance by changing color.
This is to show that the different foods in which we eat has chemicals, and through science we have been able to prove the presence of nutrients in the food we eat. Thank you.
Thank you very much. From this last experiment, we can test if we have proteins in beans. Is it possible? Okay, I've heard a lot of arguments. Thank you.
That's true. I want to congratulate all of you again. You did very well. I would like some clarification from the Valiant House. How does the extraction of DNA from a banana, how does it apply? Where can you use it?
How the extraction of DNA can be used in our daily lives. As we all know, if you go to the hospitals, the DNA from organisms help us to be able to detect genetic diseases. That's why sometimes if you go to the hospital for some special treatment, you'll be told to eat certain types of fruits because of how they can help in the improvement of your body in order to make you live healthy.
Yes, thank you very much for that answer. I was just nodding, both myself and Chief Judge. It's good to be able to rebound. You know, in basketball, they call it rebound. That was a wonderful answer. It strengthened your presentation, your ability to demonstrate knowledge of this. Again, I want to concur with my judges that this second set of experiments are even more impressive. And the beautiful thing is that whether they're middle school or high school learners, the confidence levels are wonderful. Honestly, I believe that this format of going through the stages, let us not be hasty to say, I noticed that initially you were in a hurry to end this, but you can agree with me that this science fair presentation is much, much better than the first one. Do you all agree with me? Yes, because you've had the opportunity to reflect. And I think that your reflecting ability shows the quality of the scientists that you are. Whether you study art subjects or science subjects is immaterial. You have all demonstrated that you are scientists at heart, and you must be commended. Thank you very much.
Very impressive, very practical, and very, very more than your age, if there's anything like that. I'm impressed. Thank you.
All right, thank you very much. Final round of applause for them, please, as they come up with the last set of presentation. So, presenters for the last set of presentation. Do we have anybody in the house who wants to share what he has learned so far? Presenters for the last set, please come up while we listen to those who want to share what they have learned. Anybody? House members, are you here at all? Share with us. Tell us what you've learned so far. right, we have someone who's ready to share before. Victory House, are you around? Okay, someone is willing to share what she has learned so far. Let's put our hands together for Miss Nankami, right?
From the solar oven, I've learned that instead of using gas, we can use solar ovens to save energy and money.
That's a beautiful one. We'll use solar energy to save energy and money. Are we applauding her? That was a beautiful one. Yes, any more? Okay. Okay, Ihioma wants to share.
Carbohydrates, protein, fats, and oil.
She said from the title, the food test, right? Yes, she said from the food test experiment, you can help yourself get the balanced diet you need. So you know when you're eating carbohydrates or food with fats and oil. So are we ready? Contestants, are we all ready? All right, so we'll begin the fourth presentation. We'll begin with Vision House. They'll be doing an experiment of action of enzymes, and then Victory House on electroplating, and then Valiant House on chromatography, and Conqueror House on effect of catalyst on chemical reaction. So please let's applaud Vision House as they begin.
Good morning, everyone. My name is Rebecca Richard, and I'm here to represent the Vision House. And here with me is
Felicia Abu
and Babusha Kabruk. The topic we are doing today is the action of enzymes. Now, before we start our experiment, we need to know the basic terms in what we are doing. Now, what is an enzyme? An enzyme is an organic catalyst which helps to speed up the chemical reactions in a living organism.
And what is a catalyst? Catalyst makes it happen faster. When of a reaction that ought not happen at all or would take too long to sustain life. However, a catalyst does not take part in the reaction itself. Thank you.
Now, before we start our experiment, we are going to list the materials and the procedure in what we are doing.
As for these scientific experiments are plastic cups, petri teaspoons and tablespoons, lukewarm water, hydrogen peroxide, a dish soap, food coloring, and that's all. Thank you. And for the procedures, we're first of all going to label our cups 1 to 4. After we're done labeling our cups 1 to 4, we're going to add the dish soap into the cups, which we have already done. And all of them carry the same quantity, which is 1 tablespoon of dish soap, which has already been added into the 4 cups. We're going to add hydrogen peroxide to the cups. We're going to add half tablespoon of hydrogen peroxide to cup 2. As she's doing. 1 tablespoon to cup 3. And 2 tablespoons to cup 4. So now we're going to be adding our food coloring to each of the cups. And the use of this food coloring is for us to be able to identify it. For those who are not able to see the markers, numbers that are written on the cups, we can be able to identify it by the use of the food coloring in it. After you're done with your food coloring, we're going to add our yeast solution to all the cups, and we're going to observe our results. So for the quantity, we're going to add half tablespoon of yeast solution to cup 2, 1 tablespoon to cup 3, and 2 tablespoons to cup 4. Now we're going to read and observe our experiments. So now, as we can see, the amount of foam air bubble that rose up in cup 2, 3, and 4 are different, and the one that rose up in cup 1 is different. That is because we did not add our hydrogen peroxide to cup 1. This is to tell us you have catalysts inside that breaks down the harmful substances that are in the hydrogen peroxide into heat and oxygen, which helps us to be cured from diseases like cancer of the breast, cancer of the lungs, and cancer of any part of the body. And now we're going to add yeast solution and hydrogen peroxide to cup 1 to see whether it's going to rise or not. We're going to add half to cup 1. And also half tablespoon of yeast solution to cup 1. So now as you can see, it's rising up. The name of these harmful substances are called radicals. They are called the harmful substances that are in the hydrogen peroxide, and it helps us. And the yeast solution is unharmful to the human body. Thank you.
The results presented allows us to continue to conclude that the yeast solution helps to break down the hydrogen peroxide into harmless oxygen and water. Thank you.
Good morning, judges, students, and teachers. My name is Deborah Olaniran, and with me are Alex Onyeke and Simon Issa. We are here to perform an experiment, and the title of the experiment is electroplating. I would like to hand over to Alex Onyeke.
Electroplating is the coating of one surface of a metal with another one. But in our case, we're using copper and the iron washer. So we are coating the iron washer with copper. The aim is to improve the properties of the iron washer, that is to increase the conductibility of that of copper, so that the properties of copper can be obtained, which is resistant to corrosion. Yeah.
Now, the hypothesis of this project is to be able to electroplate an iron washer with copper in order to improve, like he said, its conductivity and reduce the potential of it rusting later on in future, which is very useful. I would like to hand over to Deborah to tell us the materials needed for this experiment.
The materials that are needed for this experiment are copper rod, copper 2 sulfate pentahydrate, a 9-volt battery, copper clips, copper wires, a beaker, an electric scale, a spatula, 1 liter of warm water, and an iron washer. The procedures that are needed for this experiment are: step 1, mix a solution of 30 grams of copper 2 sulfate pentahydrate and 1 liter of warm water. Let's continue. Step 2, place the anode and the cathode in the solution about 3 centimeters apart from each other and away from the base of the beaker. Step 3, attach the wires to the electrodes using the crocodile clips. Step 4, attach the other end of the wires using the clips to the positive and negative terminals of the 9-volt battery and allow current to flow for about 5 to 10 minutes. At the end of the reaction, you observe a reddish-brown coating, which is the copper metal coating. Therefore, the iron washer has been successfully coated with the copper metal. I would like to hand over to Alex Onyeke to explain the uses.
The uses of electroplating: number 1 is used for the production of jewelry, is used for facilitating conductivity in circuit boards, is used to prevent corrosion.
So we use electrolysis to electroplate washers like this because it's easier and less expensive than using copper itself, and it also takes, I think, less time and less energy used in, for instance, melting the copper and forming it into what shape you want it to be. Now I'll hand over to Deborah for us to conclude for us.
In conclusion, the iron washer has been successfully coated with the copper, which will improve its conductibility and also prevent it from corrosion. Thank you.
Good day, everyone. Good day, everyone. I'm from Villians House, and we want to present our science project, which is chromatography. Now, what is chromatography? Chromatography is a method of physically separating mixtures into different components. There are different types of chromatography, but the one that we'll be presenting today is called paper chromatography. Inks, as we all know, whether markers, pens, etc., we don't know if it's is it a pure substance or a mixed substance. We can't see it with the human eye, but we can use it during a microscope. But the best way to do it is using chromatography. Now I'll hand it over to Ire Ogunsaya to explain more.
Our aim is to figure out the difference whether inks that are in markers and pens are mixed substances or they are pure substances. And our apparatus, those are the materials and equipment we used. We have the filter paper, gel pens or markers, eluting solution, which is medical alcohol, 250 milliliter beaker, a pencil. Now our steps. A pencil and a ruler were used to measure accurately and draw a straight line across the paper about 5 centimeters above the bottom edge. The finish line is drawn 10 centimeters above the finish line. Three small marks X of distance 1.5 centimeters between each other are made on the starting line. A small tape are used on the glass are used to the paper to a glass rod. A 250 milliliter beaker was used and put about 25 milliliters of a little solution was poured into the beaker.
As we can see, we are pouring in our medicated alcohol into the beaker. Then we take the glass rod, which is already with a filter paper and with marked spots. We use pen for this one. We don't know if the pens are pure, but we are about to find out. This takes a longer process, about like 20 to 40 minutes. So we have some finished products. This one that I hold in my hand right now is not a mixed substance. These are both blue and black board markers that our teachers use. As you can see, the finished product was a bit of orange because it got mixed. Then this is a mixed substance where we got different inks and mixed them together. As you can see, first we have color purple, then black, then a bit of blue, and then finally red and orange. I don't know how we got the orange, but it's just to say that this really works and show that when we have a mixed substance, we can see that it is not pure. Chromatography can help us in a lot of ways, not only to find out if substances are pure, but it can also help in medicines. We don't know what we take into our bodies, and we don't know whether they are pure, whether they are harmful to the health, whether they are even safe for us humans to use. So chromatography helps to find out what is in it. The mixtures is going to separate it into its different ingredients to make sure that we see the different things that are added to make that substance.
As you can see, the inks have already has begun to rise, and they'll keep going for about 60 to 80 minutes. In conclusion, we have achieved our aim of finding out whether inks are pure substances or mixed substances. Thank you.
Good afternoon, my panel of judges. my panel of judges, educators, and my fellow students. My name is Gapchong Andrew Bogoro, and here with me are Sharon Bright, Emmanuel Luca, and Coretha. So the title of our experiment is Chemical Reaction. So our aim is to show that chemical reactions can occur faster with the use of a catalyst. So a catalyst is a substance that is used to speed up chemical reactions. For this experiment, our catalyst will be yeast. So let's move on to our hypothesis. Our hypothesis is more hydrogen peroxide will produce more foam. Our scientific background. Chemical reactions involve breaking chemical bonds between reactant particles and forming new bonds between product particles. So our apparatus. Apparatus refers to all the necessary items that will be needed to carry out an experiment. So as a science student, the use of a lab coat is very important because it protects our body from chemical spillage. We'll also be using our goggles and our hand gloves. This is to protect the eyes and the skin from irritation because hydrogen peroxide irritates the eyes and the skin. We'll also be using our measuring cylinder, our yeast. We have 1 tablespoon of yeast, 2 and 3 tablespoons of yeast. So we'll be using our conical flasks, which are labeled A, B, and C. The reason for labeling is to avoid making unnecessary mistakes when carrying out experiments. So we'll also be using our spatula, hydrogen peroxide, food color, and our yeast, which is already mixed with warm water. The reason for mixing the yeast with warm water is to show if the yeast is alive. If it is alive, it's going to foam, which is already happening right now. So let's move over to our procedures. So our hydrogen peroxide has already been mixed with our food color over there. So now we'll just be adding our hydrogen peroxide, 50 ml of hydrogen peroxide. Okay, so now our hydrogen peroxide has been added into each of the cornicle flasks. The reason for using 3 cornicle flasks is to check the time rate at which each amount of yeast added will tend to react faster. So now we'll be adding our yeast into cornicle flasks A, B, and C. First of all, we'll be dropping it on the floor so that it doesn't spill on the table. Okay, so at the count of 3, we'll be adding the yeast. 1, 2, 3. Okay, A is first, B is second, and C is third. Okay, we'll be calling on Emmanuel Luca for the real-life
application. We have organic catalysts like enzymes which help to speed up the rate of digestion of food, e.g. ptyalin, which is found in the mouth on the saliva, helps to break down starch to maltose. And also, we have the inorganic catalyst, which we use in baking, e.g. where we add it to our bread to make it rise. And that's why it rised up our experiment here. Thank you.
Now we'll be inviting Sharon Bright for the results and conclusion.
For our conclusion, we concluded that conical flax C has the most catalyst, being yeast, and conical flax A has less catalyst put in it because it took the longest time to rise.
Thank you.
That was a very beautiful experiment there. This last one was a good recap. So please, judges.
Well, on a lighter note, I hope it will clean off the floor. This is what science should be. It's fun. It reminds me of the very first science fair we had. That was in the Learning Center. Incidentally, the Learning Center is 24 today. Yes. And the first science fair that we had was held, I think, in 2003 or 4, about 20 years ago. But we've never had it in the academy. And I saw this is fun. This just reminds me of the programs on Nickelodeon and all these other things. It's what would make learning catalytic, to borrow your word, for people that want to learn science. But I think the most impressive part of your presentation was your attention to safety. The fact that you were very conscious of your safety, and even where you used the goggles, it was very clear that you did not just put on your lab coats or wear your goggles or wear your gloves for wearing them sake. This is a practical demonstration of academic excellence at its best. And I think I speak not just for this experiment, but for all the experiments. It is really impressive that I cannot tell the difference between a learner that is in COE 7 or a learner that's in COE 11. The fact that each and every one of you is speaking with confidence, right from the Vision House to the Valiance to the Victory, I am really impressed. And I hope that we will use this template to learn. The competition is the byproduct. The learning is what it's all about. And I'm hoping that the educators, particularly the HOD of science, has taken note of this. It's about them learning. I don't think anyone seated here will forget. And I know that Greatest K, that's the organization that supports us in this, is already working on getting the YouTube versions. So each and every one of these experiments, each presentation will be broken down and will be uploaded to the internet on Instagram and on YouTube, so that not just you in the academy rather, but children all over the world can learn from what you have demonstrated today. This is world class, and you know I don't say that lightly. This is world class. This is as good as anything that I'll see elsewhere. But then you will say I'm biased, I am in Great Blessings. You will hear from the others that are not in Great Blessings.
I'm going to talk on a general note. Maybe I should stand to commend the management of the school. It's really awesome. It's really awesome to see a demonstration of things like this. I remember back when I was in school, they were just abstract to me. And I wondered if they were ever going to be applicable. But for you all to be able to do it and know that it really applies, that's awesome. I also commend your teachers. They've done a wonderful, wonderful job. And I just, a line in your affirmation, it says, I can do all things through Christ who strengthens me. I want you to hold on to that. You can do much more than this. and the sky is your limit for every one of you.
So let me follow my colleague to stand. Our mentor here, Professor Oladisa, has given us the chance to do something. I'm even feeling somehow that I'm the chief judge in this because she's my lecturer. Yes, she has emphasized the need for safety, but I noticed Victory House didn't put up any safety gadget, and they're using acid. Please, next time when you're having an experiment like this, I think this is acid, right? It's not acid. Tetraoxosulfate, something. Sounds like acid. What? Copper 2 sulfate and tetraoxosulfate now. That's what you used to call it in those days. The name has changed. Right? You back in nomenclature. So it's acid, right? Because there's an anode and cathode reaction happening there. And acid, we know, is very, very corrosive. Or is it diluted? It's very diluted. Okay, so it's not harmful. Okay, I can drink it. Okay, but anyhow, you have to show that you are a science person and your gadget should listen. But I'm very, very delighted of being here, and I hope there will be another time for us to be dazzled by this thing. Another thing I notice is the use of scientific wordings. The use of scientific wordings should be used. Like the other presentation, somebody was saying this work of art, this something, it should be science. When you're doing science, you go all the way science. If you're doing art, you go all the way art. So please, always use technical terms. Don't use your inside the bedroom technologies or the one that you use with your friend. Technical terms. Copper 2 tetrasulfate should be copper 2 tetrasulfate. This should be mentioned technically. Always, when you're doing technical, you see, it gives you more marks and courage. Thank you very much.
Thank you very much. So all houses, can we give them a big round of applause? This beautiful as they leave the hall and allow our judges. Okay, as they leave the hall, let's keep clapping. Let's keep clapping. Our judges will be compiling the results. Meanwhile, we have a presentation from Master Salem Kirin. Is in the house. This is of the competition. It's Master Salem Kirin. Sorry if I'm not pronouncing the name appropriately. It's Master Salem Kirin in the house. Okay, so he has a presentation on coding.
Good morning, everybody. My name is Kirin Salem, and this is my partner, Simon Hisa. So together we built a quiz app to test students' ability on basic science questions. And please, I don't know if the person will the quiz app shortly. Yes. So if you don't mind, I would like someone from the audience to please help me answer the first question here. Okay, so the question is, describe the process of cellular respiration and its importance for generating energy in living organisms. The first option is converts light energy to chemical energy. Second option, converts chemical energy to mechanical energy. Third option, builds up glucose to store energy. And the fourth option, breaks down glucose to release energy. Please, who can help us answer that? Joshua, ma'am.
The answer is breaks down glucose to release ATP.
So now, by the green that it has shown, this indicates that the answer that he has selected is the correct answer. And then by clicking the next button, you proceed to the next question. And then if the answer is incorrect, let's choose option B, by random. Sorry, option B, option A, I mean. No, but please click on the next question. Okay, let's choose option B here. So here it indicates that the option that you have selected is incorrect, and it also indicates the correct option by highlighting it in green. We used technologies as HTML, CSS, and JavaScript to build this. And it can help students to test their various abilities in different questions as regarding science. And at the end of all the questions, it shows you the amount of correct questions you have answered. Thank you.
Thank you very much. Okay, from the audience, do we have anything to say? Does anybody have something to say from what he or she has learned today? Anybody? The audience on the other side. Okay, let's put our hands together as we invite, is it Patience? Josephine, thank you.
From the experiment of the growing of bacteria, I didn't know before that there are some bacteria that are not harmful to the human body, but through the process I was able to learn that some bacteria are not harmful to the body.
Good one. All right, we'll be putting our hands together for our director for her.
So I'll take my cue from Architect Saliu and Architect Goffwen, who have graciously engaged us in this. I really wish that the parents had been a part of this, but they will have an opportunity to watch online. But let me tell you, children, a secret. There's a way your parents can participate. Do you know how you can get them to participate? Yes, you just engage them and make them know that you're going to be a part of this. Create a hype, if you will, for your parents and make them see that it's very important. I'm very impressed with Mrs. Eka, Madame Eka. She came and she has been an active part of what is going on. I can assure you that when you go to her status, if she hasn't already posted, she has put not just her daughter, but GB on. Please tell your parents. Let them celebrate you. Celebrating is not about primary school. It's about your life. And they shouldn't wait for just your milestones of graduation and marriage. There's much more to your life and excitement. I was somebody that was privileged to have parents celebrate me. We didn't have graduation in our secondary school, but I can assure you that every opportunity that I had to shine in competitions, particularly, my parents were there to support me. So you do your own bit. How many of you told your parents to come today? Let me see your hand. Okay. You told your parents to come and they didn't come. How many of them? So write your names on a paper at the end. I guarantee you I will harass your parents, so that the next time you are doing something, they will come. So today is Thursday, maybe they're at work. Make sure they come for your sports day. It's going to be on a Saturday. They do not have any excuse not to come. And I hope that the Greatest K will do something for me. Just make a segment of my talking to parents like this, so that I will upload it to the parents chat, those that care to go online. Thank God for weddings. Thank God for programs. But I think that the highest set of people we can celebrate are our children. Their gift, their heritage, and their reward. So back to those of you that are seated here. How many of you think that you want to go into science? Let me see your hands. You are in middle school. I especially interested in middle school. Let me see your hands. Middle school learners. How many of you, after this experience, think that science is easier than you imagined before now? I can see it's everybody. So, Mr. HOD, you have done a wonderful job. At this point, I want to acknowledge some people. I know you're going to do a vote of thanks, but I want to acknowledge two very special people. One of them is a parent, and one of them is someone very close to me. Benjamin Yisa is a veritable resource from the day that we know him. You know Architect Ben now, Ben Yisa, yes. He has been, you're hearing all this architect. It's not because they're architects, but I know that part of being an architect is being a problem solver. So invariably, these are the people that we go to. He is being felt. His presence is permeating everything that we are doing. I'm just as if he's here, but he's not here. I just want to use this as an opportunity on behalf of staff and management of the organization to appreciate him. He's bereaved of his father. If not, I know he would have been here. Grandpa is a fantastic scientist too. I can still hear him say Sokomba in their house. I won't tell you who Sokomba is. Those of you that know who Sokomba is, calling somebody to do this and that for him. And the other person happens to be my husband, Professor James Adisa. You thought it would be my son. Yes, my son, Shobai Ola Adisa. They have worked tirelessly with Mr. Matthew. Mr. Matthew would say more about that when he has his opportunity. Science department have set the stage. I don't know if it's because they are the largest department in the academy. They have about 11 of all the subjects that you do, both in middle school and high school. Science department have set a standard. I'm expecting to see a fantastic quiz output from here. You have done very well. At the end of the day, you're going to hear scores, but it's not about the scores alone. It's about the knowledge you are able to translate this to. So I want to appreciate Mr. Matthew Samuel, or Mr. Samuel Matthew. I'm becoming like Mr. Falano that says Chinese. Please, we don't introduce ourselves. And I heard some learners saying your surname first. You're not Chinese. Say your name and then your surname after, okay? Since we are Nigerian and we use the British method here. I want to appreciate you. Thank you very much, Mr. Matthew. You know, when we started this, you were wondering how it will work, but it took the mind of a physicist along with the mind of a chemist. The chemist is nodding her head, I can see, a biologist, and all, indeed, even the political scientist. Is politics, but there's science in it, ma'am, catch, right? Many of you don't know that our principal is a scientist too, just the political kind. So you've done very well. Of course, there are lots of areas for correction, but this is a day of celebration. I'm sure when we do our analysis and we go over things, we'll see where we can do things better. But by and large, I have been educated, and I can speak for everyone here. I believe the judges are through. Is that the next thing? Yes. Aha. So I invite Architect Chalia. These are my people. Architect Bala, you are my. I've known you for how long now? Since 2001. You were doing your. Were you doing your masters? Yes, he was doing his masters. When I first started teaching in University of Jos, they were my students, and I was very surprised about him. I will tell the story. I know you don't want me to say it. You see, Architect Bala here was one of the most unserious students in my class. Always joking, always laughing. Now, when I mark my scripts, I don't look at their names. I just go by the math number. So when I marked and I saw the exam and I saw somebody trying to collect all the marks, I stopped where I was going. I normally will wait and collate. I said no. After I finished marking, I now went to go and check. I checked. I saw his name. I checked again. I could not believe it. One of the best performances in my exam till date. And I've been teaching that course for over 20-something years. So him and Agiola Dan, sorry if he hears this, I couldn't believe it because they were very playful, but extremely brilliant. And I'm hoping that he will bring his chess to the academy. He's one of our chess masters. He was supposed to have brought it to the learning center, but didn't work. I'm hoping that you bring chess to the academy. There's something about the chess brain that helps. How many of you are interested in learning chess? Let me see your hands. Good. So, Architect Bala, look. You see, boys and girls. So, he, and then Architect Chalia too, I was privileged to supervise her MSc. Yes. She was one of the best MScs in her time, and now I'm co-supervising her PhD. They are both doctoral candidates. They will soon be doctors. Don't mind how young they look, especially her. Yes, she looks very young, but they are both doctors. By this time next year, you'll be calling them doctors. So I'm really, really happy that they are here and that they honored our invitation. The last time you saw Architect Ella, even though it was remotely, also the similar relationship. I think he's in your class. Yes, he's a doctoral candidate as well. I'm saying this so that you children will know how highly we rate you. We are not just bringing anybody off the road to come. We are not just bringing architects of high repute, but we are bringing architects that have a research background to help you, and also the educators for you to know how highly we rate you too. Thank you very much.
Okay. As it has been said, this is not to say that some people did badly and some were at the top. Everybody performed above average, and that's very good. I don't know where our scientists, they are outside.
Okay, all presenters and house captains,
You
please,
may want to come and
can you come up? This is the moment we've been waiting for, so let's come up. House masters and mistresses, please come up. House masters, house mistresses. House masters, house mistresses.
So can we give them a round of applause? A loud one. I don't know. So for the modeling project, in fourth place is the Conqueror House. They had over 45 points, 45.6 points. And then in third place is the Valiance House. In second place is the Vision House. And in first place is the Victory House. For the experiments, it's an accumulation of the 3 experiments. Yeah, 3 experiments you did. I will start with the 4th place. The 3rd place, actually, because it's a tie. It will be, that's the, okay, this is a bit peculiar. The 3rd place is the Victory House for experiments, right? Then the 2nd place is the Vision House. So what it means is that we have 2 first positions, Valiance and Conqueror House. Now from the modeling and experiments, the whole presentation for today, 1st place is Valiance House. 2nd place is Victory House. 3rd place is Vision House. And 4th place is Conqueror. So well done, guys.
Wow. Wow, wow, wow. Okay, please, I think we forgot something. The teachers who worked with these children, please, learners, can we please applaud them? They did a fantastic job. I know it wasn't easy. Okay. Thank you very much. And the learners, I was so surprised. You know, I've taught most of you in your middle school, and I saw the boldness. I was wowed. So please, let's applaud these learners. Let's applaud them. Some of them, I know them to be very, very shy. Let's applaud them. And please, can we have music on the background? Can we have music? Stand up for the champion on the background. You all did well. You all did well. Learners, I'm not hearing any shouts of joy from anywhere. Are you not happy? All right. Well done, everyone. Well done. A round of applause, a final round of applause.
I was built to be the best.
Okay.
Number
Matthew,
one,
not to waste any
nothing
time,
less.
Mr. Matthew.
Lead me to my destiny. I have
All right, thank you very much.
patiently.
All right, at this juncture, I would like to first and foremost thank God Almighty, even for the gift of today. I think it's a privilege that we are all here to experience this. We've started, actually, just as the director have said, you know, being the maiden edition of this project. And when she brought it at the first time, you know, I was like, I've never been into this, okay, or have an experience of this. But through the work, I've also seen better ways as an educator through which I can relate to my learners. And I want to believe that the educators that have really worked closely or closer with them will bear me witness as well. So I want to say thank you all for your coming. Now, I want to first appreciate the director, the school management for this great opportunity which we have to explore in this capacity. And I think it has actually widened our scope in the area of science. And I believe that more is coming because, as I've said earlier, this is just the first edition and we are building, it's a build-up, and we are work in progress. And I want to assure you that the next science fair competition is going to be greater and more beautiful than the one we've experienced today. Thank you. So I also want to thank the judges, even though we've started the first one, they were not here, but we want to thank the person of Shobai, Professor Adisa. They were quite instrumental in adding, Mr. Hassan, giving us the background of how, I think the first one was quite intensive. Like, we took a lot of time because there were a lot of corrections, things, and I believe the effect of the correction we are actually seeing here. Thank you very much. And want to thank the person of architect Bala Salihu. Thank you, sir, for your presence, and thank you for all the value addition. Want to also thank the architect Chalia, Gufuen, sorry, I didn't put the name. Thank you very much for honoring this science fair. We want to say thank you. And I also want to thank all the educators for their tireless efforts, put in place. Despite the fact that we just resumed last week, and then this science fair is coming, it was quite short for us, and then the effort put in place, a lot of things, with a lot of deliverables on our tables, but then we are able to see that we put our best. Can we please clap for our educators for a wonderful job well done. I also want to thank our uncle. Yes, thank you for your presence and thank you for the wonderful anchoring. Also want to thank the GB media team for their unwavering support too. Whenever we call on them, they are always here to set up the place, and then we really have the greatest key. Thank you very much. And also the learners that have participated, and others. We have a lot of them that have participated, but then we have only few that are here to present with us. So it means that they have all learned all the things we have seen here today. Thank you. Can we please can we also appreciate them with a clap offering? Thank you very much, and thank you very much.
So have we learned today? Have we learned today? Was this a waste of time? Are you sure? Okay. Thank God we learned a lot, and we are still going to learn more. Okay, so at this time, we'll welcome Mr. Emmanuel Abu. Am I correct? Okay, Mr. Emmanuel Abu for the closing prayer.
Before I pray, I would like to say this. I think I'm going to be a science student. I want to change because what I've seen here, honestly speaking, it's mind-blowing and it's quite impressive. Thank you, Director, for this initiative. I'm really learning very fast. Please, let's pray. Stand, please. We begin this prayer in the name of God, the Father, the Son, and of the Holy Spirit. Amen. Almighty God and Father, we thank you for a day like this. We thank you for the initiative you've given the school and to also present these kinds of wonderful things we've done today. Lord, indeed, we believe in your word in Isaiah chapter 8, verse 18, that the children the Lord has given us from Mount Zion are portents in Israel. They are for miracles, they are for signs, and they are for wonders. Lord, we thank you for everything that ensued in the course of this day. Lord, we ask for greater heights. Open up to broader horizons of knowledge. Father, may this little act we've done this day shoot this school, make school more public, and also attract every other learner to this school in the mighty name of Jesus. I lift up my eyes to the hills, from where does my help come? My help comes from the Lord who made heaven and earth. He will not let your foot be moved. He who keeps you will not slumber. Behold, he who keeps Israel will neither slumber nor sleep. The Lord is your keeper. The Lord is your shield at your right hand. The sun shall not smite you by day, nor the moon by night. The Lord will keep your life. He will keep your going out and your coming in from this time to you. May he turn his countenance towards you and grant you his everlasting peace, both now and forevermore. Amen. In the name of God the Father, the Son, and of the Holy Spirit. Amen.
Stand up, stand up, stand up for just who wants it most. It's just life, that's how it is. 'Cause we have our strengths and weaknesses. Oh, I have vision, oh, can't you see? I'm on the move, make way for me. So stand up for the champions, for the champions. Stand up, stand up, stand up for the champions, for the champions. Stand up for the champions, for the champions. Stand up, stand up, stand up for the champions, for the champions. Stand up. And when I fall down, I have to pick myself back up.